In this video, we'll quickly go through all the formulas and rules that we have in indefinite integration, which we require in understanding the fundamentals of physics. However, there is one rule, that is rule of substitution, which I'm not going to cover in this video as it will be covered in the next video. So let's get started. Let's begin with the definition. So if we have a mathematical statement written in this form, then first of all, what this symbol signifies? Well, this is the integral sign. And what is the small f of x? This is called as integrand. And this x is the variable of integration. And this capital F of x on the RHS, it is the antiderivative of small f of x. So basically, this small f of x is a function. We're trying to integrate it. What is meant by integrating a function? It is to obtain another function such that if you differentiate that function, you again get the same function. For example, if we try to integrate small f of x with respect to x, we should get a function in such a manner that if we differentiate this function, we again get small f of x. And this is why it is called as antiderivative, because it is the reverse process of differentiation. And why this constant sign is over here? Well, that is because if you look at the RHS side, you try to differentiate it, then the differentiation of this constant is going to be 0, and therefore there will be many functions on the RHS side whose derivative is going to be small f of x. So we can memorize it that if we try to differentiate a function, we get only one function as its derivative. However, if we try to integrate a function, then we get set of functions as its antiderivative, and all such functions are going to differ by a constant c, and that's why we have this constant sign over here. And this integration where we do not know about what is going to be the constant, and this type of integration is called as indefinite integration. Let's now talk about the formulas and rules in the integration. So the first formula would be, if we have a function x raised to power n, well, as this n is a constant, it can be just anything. And if we want to integrate it with respect to x, that means we have to write it in this manner. Then it is going to become equal to x raised to power n plus 1 divided by n plus 1 plus constant c. Remember, we can use this formula for all values of n except minus 1. So this formula is not used if n is equal to minus 1. So we'll just write it over here. Well, we have a special case in this. Let's say we have a linear expression in x. Let's say it's a binomial expression ax plus b, and it is raised to the power n is there. And if you want to integrate this, then in this case the integration is going to be equal to ax plus b to the power n plus 1 divided by a times n plus 1. Basically, this a is the coefficient of x. So again, this formula to be used for n not equal to minus 1. So this is the first formula. Let's talk about the second formula. Second formula, what if this n is equal to minus 1? That means we're talking about a case where we have to integrate 1 by x with respect to x. That means we want to find out integral of dx by x. So this is going to be equal to ln of x plus c, which is obvious because if you try to differentiate ln x, it is going to be 1 by x. So the integration of 1 by x is going to be ln x. Now in this also, we might have a special situation, that is we want to find out the integration of 1 upon ax plus b. So it is going to become equal to ln of ax plus b divided by coefficient of x, which is a plus c. Remember that this formula is to be used only when we have a linear expression in x. If it is x to the power 2, 3, or there is some other thing apart from this linear expression, then we cannot use this formula. Next is, if you want to integrate e to the power x dx, what will be its integration? It is going to be equal to e to the power x plus c, because if you differentiate e to the power x plus c, you will again get it as e to the power x. And in fact, again, the special condition in this would be that if it is e to the power ax plus b, if you want to integrate it with respect to x, then you are going to get it as e to the power ax plus b divided by coefficient of x a plus c. Now, what is the integration of ln x? Well, the integration of ln x is not going to be required. Sometimes you get confused and you write integration of ln x as 1 by x. Well, that is a derivative of ln x and not the integral of ln x. Well, this is not going to be required, so we will not unnecessarily burden ourselves with unnecessary informations. Fifth, what is the integration of sine x dx? Well, it is going to be equal to minus of cos x plus c. Again, we have a special case in this. If it is sine of ax plus b, which is a linear expression in x, then its integration is going to be equal to minus of cos of ax plus b divided by coefficient of x is a plus c. Next, integration of cos x dx. It will be sine x plus c. Again, what is the integration of cos of ax plus b dx? Well, it is equal to sine of ax plus b divided by a plus c. Next is, what is the integration of tan x dx? Well, it is not going to be required. But if you really want to know what is the integration of tan x, then we can use rule of substitution to find out integral of tan x, which we will do in the next video. Similarly, the integration of sec x dx is not going to be required. Also, cosec x dx will not be required. Cot x dx will also not be required. Let's now talk about the integration of sec square x dx. Well, this is going to be equal to tan x plus c, because the derivative of tan x we already know, it is sec square x. Next, what is the integration of sec x tan x? Well, this is going to be equal to sec x plus c, because the derivative of sec x is sec x tan x. Next, what is the integration of cosec x cot x? Well, this is going to be equal to minus of cosec x plus c. Why minus? Because the derivative of cosec x is minus cosec x cot x. And next, what is the integration of cosec square x dx? Well, this is going to be minus of cot x plus c. Why? Because the derivative of cot x is minus cosec square x. Now remember that in all these formulas, wherever we have ax plus b in place of x, that means it's a binomial linear expression in place of x. Then, for example, in sec square, ax plus b is there, then it is going to become tan of ax plus b. And in the denominator, there will be coefficient of x, which is a. So everywhere we will do it in the same manner. If we have ax plus b, it's a binomial linear expression in place of x. Let us now talk about the rules in the indefinite integration. The first rule would be, if we have a situation that a constant is multiplied by a variable and we want to integrate this expression with respect to x, then this constant can be taken out of this integral sign, so it can be written as c times integration of f of x with respect to x. So it was the first rule. Let's talk about the second rule. If we have two or more than two terms like this, let's say it is f of x plus minus g of x, and we want to integrate this entire expression with respect to x, then the indefinite integration is going to follow the distributive property, and hence we can write it as integration of f of x with respect to x plus minus integration of g of x with respect to x. Let's talk about the third rule. What will happen if the two variables, they are in multiplication, they are in product? So let's say we have f of x multiplied by g of x. So what will be its integration with respect to x? Well, many people do it like that. It is going to be f of x integration of g of x with respect to x plus g of x integration of f of x with respect to x. I must tell you that this is not going to be true, because in case of indefinite integration, there is nothing like product rule or quotient rule. So you must remember that it is not going to be equal to what we have done. Now let's talk about the last rule that we will require, although there are many more rules, but we will not go beyond the fourth rule, that is the rule of substitution. Well, I have already told that the rule of substitution, will be doing it in the next video. So as far as the basics of indefinite integration is concerned, this is all about it. And if you want to practice problems specifically related to indefinite integration, then you can check out my application whose link is provided in the description box below. Thanks for watching.